Okay, hi everyone, welcome back to this video series on data centers, testing your IP routing understanding. I really want to make sure you understand IP routing because it's super important. So I'm going to use this section to test your understanding of the IP routing process by having you look at a couple of figures and answer some very basic IP routing questions. Figure 9.4 shows a LAN connected to router A, which is in turn connected via a WAN link to router B. Router B has a LAN connected with an HTTP server attached. The critical information you need to glean from this figure is exactly how IP routing will occur in this example. I'll give you the answer, but then you should go back over the figure and see if you can answer example 2 without looking at my answers. The destination address of a frame from host A will be the MAC address of the FA0/0 interface of the router A router. The destination address of a packet will be the IP address of the network interface card NIC of the HTTP server. The destination port number in the segment header will be 80. That example was a pretty simple one, and this was also very to the point. One thing to remember is that if multiple hosts are communicating to the server using HTTP, they must all use a different source port number. This is how the server keeps the data separated at the transport layer. Let's mix it up a little and add another internetworking device into the network and then see if you can find the answers. Figure 9.5 shows a network with only one router but two switches. What you want to understand about the IP routing process here is what happens when host A sends data to the HTTPS server. The destination address of a frame from host A will be the MAC address of the FA0/0 interface of the router A router. 2. The destination address of the packet will be the IP address of the network interface card NIC of the HTTPS server. The destination port number in the segment header will have a value of 443. Notice that the switches weren't used as either a default gateway or another destination. That's because switches have nothing to do with routing. I wonder how many of you chose the switch as the default gateway destination MAC address for host A. If you did, don't feel bad, just take another look with the fact in mind. It's very important to remember that the destination MAC address will always be the router's interface. If your packets are destined for outside the LAN, as they were in these last two examples, before we move into some of the more advanced aspects of IP routing, let's discuss ICMP in more detail, as well as how ICMP is used in an internetwork. Take a look at the network design shown in figure 9.6. Ask yourself what will happen if the LAN interface of router lab C goes down. Lab C will use ICMP to inform host A that host B can't be reached, and it'll do this by sending an ICMP destination unreadable message. The point of this figure is to help you visualize how ICMP data is routed via IP back to the originating station. Let's look at another problem. Look at the output of the corporate router's iOS routing table. SHIP route output cut 192.168.2.15.120/2 via 192.168.20.2 00:00:23 serial 0/0 or 192.168.115.0.120/1 via 192.168.20.2 00:00:23 serial 0/0 192.168.30.0 120/1 via 192.168.20.2 00:00:23 serial 0/0 C 192.168.20.0 is directly connected serial 0/0 C 192.168.214.0 is directly connected fast Ethernet 0/0. What do we see here? If I were to tell you that the corporate router received an IP packet with a source IP address of 192.168.214.20 and a destination address of 192.168.22.3, what do you think the corp router will do with this packet? If you said the packet came in on the fast Ethernet 0.0 interface, but since the routing table doesn't show the route of network 192.168.22.0 or default route, the router will discard the packet and send an ICMP destination unreachable message back out interface fast Ethernet 0/0. You're a genius. The reason it does this is because that's the source LAN from which the packet originated. Now let's check out another figure and talk about the frames and packets in detail. Really, we're not exactly chatting about anything new. We're just making sure that you totally, completely, fully understand basic IP routing. That's because this book and exam objectives is geared toward all about IP routing, which means you need to be all over this stuff. We'll use figure 9.7 for the next few questions. Referring to figure 9.7, here's a list of all the questions you need and answers to emboldenize in your brain. 1. In order to begin communicating with the sales server, host 4 sends out an ARP request. How will the devices exhibited in topology respond to this request? 2. Host 4 has received an ARP reply. Host 4 will now build a packet, then place this packet in the frame. What information will be placed in the header of the packet that leaves host 4 if host 4 is going to communicate to the sales server? 3. At least the lab A router has received the packet and will send it out FA 0/0 onto the LAN toward the server. What will the frame have in the header as the source and destination address? Host 4 is displaying 2 web documents from the sales server in 2 browser windows at the same time. How did the data find its way to the correct browser window? The following should probably be written in a teensy font and put upside down in another part of the book, so it will be really hard for you to cheat and peek. But since it's actually you who's going to lose out if you peek, here are the answers. 1. In order to begin communicating with the server, host 4 sends out an ARP request. How will the devices exhibited in the topology respond to the request? Since MAC address must stay on the local network, the lab B router will respond with the MAC address of the FA 0/0 interface, and host 4 will send all frames to the MAC address of the lab B FA 0/0 interface when sending packets to the sales server. 2. Host 4 has received an ARP reply. Host 4 will now build a packet, then place this packet in the frame. What information will be placed in the header of the packet that leaves host 4 if host 4 is going to communicate to the sales server. Since we're now talking about packets, not frames, the source address will be the IP address of host 4 and the destination address will be the IP address of the sales server. 3. Finally, the lab A router has received the packet and will send it out FA0/0 onto the LAN toward the server. What will the frame have in the header as the source and destination address? The source MAC address will be the lab A router's FA0/0 interface and the destination MAC address will be the sales server's MAC address. All MAC addresses must be local on the LAN. Host 4 is displaying 2 web documents from the sales server in 2 different browser windows at the same time. How did the data find its way to the correct browser windows? TCP port numbers are used to direct the data to the correct application window. I've got a few more questions for you before you actually get to configuring routing in a real network. Ready. Figure 9.8 shows a basic network and host 4 needs to get email. Which address will be placed in the destination address field of the frame when it leaves host 4? The answer is that host 4 will use the destination MAC address of the FA0/0 interface of the lab B router, which I'm so sure you knew, right? Look at figure 9.8 again. Host 4 needs to communicate with host 1. Which OSI layer 3 source address will be placed in the packet header when it reaches host 1? Hopefully you know this. At layer 3, the source IP address will be host 4 and the destination address in the packet will be the IP address of host 1. Of course, the destination MAC address from host 4 will always be the FA0/0 address of the lab B router, right? And since we have more than one router, we'll need a routing protocol that communicates between both of them so that the traffic can be forwarded in the right direction to reach the network in which host 1 is attached. One more question and you're on your way to being an IP routing genius. Again, using figure 9.8, host 4 is transferring a file to the email server connected to the lab A router. What would be the layer 2 destination address leaving host 4? Yes, I've asked this question more than once, but not this one. What will be the source MAC address when the frame is received at the email server? Hopefully you answered that the layer 2 destination address leaving host 4 will be the MAC address of the FA0/0 interface of the lab B router, and that the source layer 2 address that the email server will receive will be the FA0/0 interface of the lab A router. If you did, you're all set to get skinny on how IP routing is handled in a larger network. Summary. This chapter covered IP routing in detail. It's extremely important that you really understand the basics we covered in this chapter, because everything that's done on a Nexus, which typically will have some type of IP routing configured and running. You learned in this chapter how IP routing uses frames to transport packets between routers and the destination host address. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.